Hey everybody, this is Mr. McKee again with Net 125. I'm going to be going over Lab 7.3.7, which is View the Switch MAC Address Table. Now, what I did, I just set up a topology that mirrors what we're looking at right here, because this would require us to actually set up some physical switches, and I'm going to see if it works with packet tracer just as good as physical switches. I will be doing some labs, hopefully, with physical switches, showing you guys how everything plugs together, or connects together. But for now, this should work fine. All right. So there's our addressing table. We'll need to know that. And what I'm going to do too, I'm going to say, okay, this is switch 1. All right, this is going to be switch 2. All right, this is going to be PCA, and this is going to be PCB. All right, I'm going to save this. All right, so this will be the version of the file that you guys will get on the submission link in Moodle. And I'm going to go ahead and configure it. All right, so the purpose of Layer 2 LAN switch is to deliver Ethernet frames to host devices on the local network. The switch records host MAC addresses that are visible on the network and maps those MAC addresses to its own Ethernet switch ports. The process is called building the MAC address table. When a switch receives a frame from a PC, it examines the frame source and destination MAC address. The source MAC address is recorded and mapped to the switch port from which it arrived. Then the destination MAC address is looked up in the MAC address table. If the destination MAC address is a known address, then the frame is forwarded out of the corresponding switch port associated with the MAC address. If the MAC address is unknown, then a frame is broadcasted, remember, with all Fs for the MAC address, out all the switch ports except the one from which it came. So it goes out everything but from where it came from. So PCA, it's connected to FA06. It won't go in that, back out that port, but all the other ports. All right, so where are we at? It is important to observe and understand the function of a switch and how it delivers data on the network. The way a switch operates has implications for the network administrators whose job it is to ensure secure and consistent network communication. All right, switches are used to interconnect and deliver information to computers on local area networks. Switches deliver Ethernet frames to host devices identified by network interface card MAC addresses. All right, in part 1, you will build a multi-switch topology with a trunking link, and this is a trunking link right here in our case. Notice it is a crossover cable, not a straight through cable like these other two are going from switch to PCs. In part 2, you will ping various devices and observe how the two switches build their MAC address tables. Alright, and it says the switches are used or cataloged to 2960s. Alright, but we should be able to use what we got right here. Alright, and ours do not have any startup configs in there. And I'm going to try to remember not to save this. I've already saved it just the way it's set up with no configurations. Alright. And just a note right here, the fast Ethernet switches on Cisco 2960 switches are auto-sensing, and an Ethernet straight-through cable may be used between switch 1 and 2, but I didn't do that. I just wanted to do it correctly. Alright, if using another model of Cisco switch, it might be necessary to use a Ethernet crossover cable. Alright, so build and configure the network, cable the network according to the topology, that's done for you. Configure PC hosts. Alright. Now it says configure the PC host, so let's go up here. And PCA is right there. We'll go to desktop. 2.168.1.1. All right, we're going to leave the default gateway off. All right, so that's all we need for that one. PCB, let's do this. 192.168.1.2, tab down, verify, okay, it is a class C address, so that subnet mask is fine. Alright, so let's get back to what we were doing. Initialize and load switches as necessary, configure basic switches, basic settings for each switch. Alright, remember, configure the device name, configure IP address as listed in the addressing table, assign Cisco as the console and VDY passwords, assign Cisco as the privileged exec password. Alright, so remember, first thing we got to do, since nothing has IP addresses yet configured on the switches, you can't just open up a PC, open up a terminal, and just connect. It's not able to connect like that. We would have to go down here, get our console cable, and what I'm going to do a console cable from PCA to S1, and then a console cable from PCB to S2. Alright, so that should be good now. Alright, so configure device name. I'm going to go up here. So I'll go here, I'm going to go to desktop, terminal. Alright, notice how it's loaded now. And don't get confused. Remember, if you see up here, it says it's PCA, but we're in the terminal, and we're remoted into with the console cable. Well, actually, not even remoted. We have a console cable plugged between PCA and S1. All right. Notice our prompt has switch still, so let's go to enable big T and hostname S1. All right. And we're going to do interface VLAN 1. What is it? IP address 192.168.1.11. All right. Remember, I got to turn it on, so no shutdown. All right, so that one's up. Now I think that's all that needs to be configured. Okay, so we need to do assign Cisco as the password for the console. I believe we can do it from here, but let me see. Alright, so I had to use exit, go back, line, console, 0. Alright, and we're going to do password, Cisco, remember login, line, maybe line BTY 0 to 15, password, Cisco, login. It's good to practice that over and over again, just to more or less muscle memory. Alright, so let's exit out of that. So we do an enable password class. It doesn't say to do it encrypted, but I probably would do that. But enable password class. If we do exit, show run, we notice host name is configured, enable password is configured, spacebar down, interface VLAN 1 SVI is configured, and Cisco password is configured for everything. Alright, so that one's good. So let's go over to PCB, and we're going to do S2's stuff. Alright. If you're still having to look up all these commands or just watch me and reproduce it, it takes a little while to get all the commands down. Alright, enable config T. Alright, so first thing, host name. I'm going to change that to S2. Alright, I'll do the interface VLAN 1 IP address 22.168.1.12 255.255.255.0. Alright, remember, host shutdown, turn it on. Alright, and I don't want to get the passwords backwards, so let me look. So let's go back, exit. Alright, so line console 0, password Cisco, log in. Alright, line 0 to 15. Oh, if you don't spell it right, it doesn't know. Alright, password Cisco. Alright, exit out of that. Enable password class. Alright, and from here I can do a do show run. Do lets you go back one without actually exiting. Alright, so hostname S2, enable password class. There's my IP address. Let's verify that that's correct. Alright, and then console and the BTOI lines are all Cisco. Alright, so we stopped at right here. The switch learns MAC addresses and builds MAC address table as network devices initiate communication on the network. Open a command prompt on PCA and PCB. Alright. We'll do ipconfig all. Alright. What are the Ethernet adapter physical addresses? You guys should be able to see those. Alright, one for PCA, one for PCB. Alright, and then console into switch 1 and 2 and type the show interface interface F01. So I'm going to go back. Alright, from the terminal, remember I'm connected into S1 there, and then here I'm connected into S2. So let me exit out of that. Alright, so S1, we're supposed to do show interface F01. Alright, on the second line of the command output, what is the hardware address or burned in address? BIA, it's right there. Alright, Yeah, that's super small, but hopefully you guys can see that. Alright, then over here, show interface F01. Alright, and there's the address right there. Alright, so console into switch 2, which is the switch 2 right here. Notice if I get confused, I can look at the command prompt and maybe Control C to get out of that. Alright. Enter privileged exec mode, which I'm at right now. Alright, show MAC address table. Alright. So even though there has been no network communications initiated across the network, it's possible that the switch has learned MAC addresses from its connections to the PC and the other switch. Are there any MAC addresses recorded in the MAC address table? Well, yeah, we have one that's connected to FA01. And if you notice here, it knows that one, the other switch. And what is the MAC address located in the table? Well, it's right there. Okay. To which switch port are they mapped, and to which devices do they belong? Well, if you look right there, if I go over here, actually I can't do that. Go over here, and just right there, that's the same one on switch 1. Same MAC address. So it's looking at the MAC address on the interface of FA01 for switch A. Alright. So let's ignore MAC addresses that are mapped to the CPU. Alright. If you had not previously recorded MAC addresses of network devices in step 1, how could you tell which devices the MAC addresses belong to using only the output from show MAC address table? You could answer that. You could probably do it just like I did it, if you didn't know. Alright. This is working all scenarios. You can put that down, but I'll let you guys answer that yourselves. Alright, so it wants us to clear the S2 MAC address table and display the MAC address table again. Privilege exec mode, type the clear MAC address table dynamic. Clear MAC address table dynamic. Alright. Quickly type in show MAC address table. It's already back. Alright, clear. Show. Alright. So, did it quick. Alright, now it's empty. If you wait for like 2 seconds, it pops back in there. Alright. Does the MAC address table have any addresses in it for VLAN 1? Well, not now, if you do it really fast. Are there any other MAC addresses listed? You guys can answer that. Wait 10 seconds. Show the MAC address table command, and then press enter. Alright, you're going to keep getting that one from the other switch. Alright, now from PCB, ping the device on the devices on the network and observe the switch MAC address table. Alright, from PCB, open a command prompt. Control C to get out of that. ARP A. All right. Not including multicast or broadcast addresses, how many device IP to MAC address pairs have been learned by the ARP? Nothing. Hopefully this works in Packet Tracer. From the PCB command prompt, ping PCA, S1, and S2. If you don't remember the IP addresses, you can go up here. And I'm going to ping 92.168.1.1. Alright, I'm going to ping 1.11. Alright, got that, and I'm going to ping 12. Alright, let it do its thing. Alright, so everything had a successful ping. Alright, let me find where I was at. All the way down here. Alright, so I'm on step 4 from PCB, open the command prompt and type PC ARP A. Well, actually, I did that. Alright, I pinged all the other 3 devices. Did all the devices successfully reply? You can answer that. From the console, well, it doesn't have me show the ARP table on PCB, but ARP A, okay. So let's see, we want to do S2, so that's on PCB, but we're going to go through the terminal. Alright, let's do show. Look at the history. Alright. So now look, since we've got pings from pretty much going across the network for everybody, that shows what's going on the network. You notice right here, FA Fast Ethernet 018 is going to PCB, so that should be PCB's MAC address, and then everything else is going through out FA01. So it knows where to send all the traffic. All the traffic for the other 3 devices will go out that way, coming from this side of the network. Alright. Has the switch added additional MAC addresses to the MAC address table? Yes. If so, which MAC addresses and devices? You guys could see those, but that's pretty much everybody on the network. Alright. So on PCB, which we're on, go to the command prompt. I can go ahead, if it lets me get in there. Come on. Okay. Let's do an up arrow. Alright, now look how it's learned other addresses. Alright. And just to be sure, before I touch anything else, PCB is .2, so these are the other three devices on the network. Alright. Does PCB ARP cache have additional entries in the network devices that were sent pings? All of them are in there now that it pinged. Alright, reflection question. On Ethernet networks, data is delivered to devices by their MAC addresses. For this to happen, switches and PCs dynamically build ARP caches and PC address tables. With only a few computers on the network, this process seems fairly easy. What might be some of the challenges on larger networks? Well, I'll let you guys answer that, but just think about being on another network with multiple intermediary devices, like switches and things like that. It's going to get a lot more complicated, so you can just explain why that would be a challenge. Alright, but that's it. You guys can use this. I'll actually upload this packet tracer. I'm going to close that down exit. All right, so you have to do all your configurations, but I'll have it physically cabled through Packet Tracer. All right, and that's it. Thanks for watching.